A DC motor turns electricity into motion. Sounds simple, but what actually happens inside? Let's open it up and find out. Inside the motor, there are two permanent magnets. I've colored them differently to distinguish the north and south poles, but remember, every permanent magnet has both a north and a south pole. At the center is the armature, the rotating part of the motor. It's made of a laminated iron core wrapped with insulated copper wire. Let's remove the bearings for a closer look. The armature is connected to a commutator, a rotary switch that reverses the direction of current as the motor spins. The commutator is in contact with carbon brushes, which transfer electrical power to the rotating armature. The brushes are connected to a DC power source. Now, let's see how electricity makes the motor spin. When electric current flows from the brushes, through the commutator and into the armature windings, it creates a magnetic field around the coils. This turns the armature into an electromagnet. At this moment, the right brush is connected to the positive terminal. According to the right-hand grip rule, the direction of the current determines the direction of the magnetic field, creating a north pole at one end of the armature. The magnetic field of the electromagnet now interacts with the permanent magnets. Opposite poles attract, while like poles repel. These magnetic forces produce torque, causing the armature to rotate. But there's a problem. Without the commutator, the armature would stop after rotating about half a turn. This is where the commutator becomes essential. As the armature rotates, the commutator turns with it because both are mounted on the same shaft. As a result, the brushes switch to the next commutator segment. This reverses the direction of current flowing through the armature windings. Because the current is reversed, the magnetic poles of the electromagnet also reverse. Again, according to the right-hand grip rule, the armature forms magnetic poles. But this time, the end of the armature becomes the south pole. This keeps the magnetic forces producing torque in the same direction. As the armature continues rotating, the commutator keeps switching the electrical connections. The previous winding is disconnected, so it no longer carries current and no longer acts as an electromagnet. Meanwhile, the newly energized winding becomes an electromagnet. Once again, attraction and repulsion between the electromagnet and the permanent magnets produce torque in the same direction. This switching process repeats continuously. As a result, the magnetic forces keep pushing the armature in the same direction, allowing the motor to spin continuously. And that's how a DC motor converts electrical energy into mechanical motion. From electric fans and toys, to power tools and electric vehicles, this simple principle powers countless machines around us every day.